Okay, this video is going to go over the 9.4 homework, starting with number 1. It says, go ahead, exercises 1 through 4. The 4 conjectures are consequences of the inscribed angle conjecture. Prove each conjecture by writing a paragraph proof or a flowchart proof. Use reasoning strategies such as thinking backwards. Apply previous conjectures and definitions and break a problem into parts to develop your proof. So I'm going to start by making some observations before I get into the proof. Notice that I have some inscribed angles here. Such as angle ACD and angle ABD. I notice that they both intercept the same arc, which is arc AD. And I also notice when I look at my conjectures list, I notice that I have a conjecture that says the measure of an angle inscribed in a circle equals half the measure of the intercepted arc. So the measure of this inscribed angle equals half the measure of the intercepted arc AD, which means the measure of the other inscribed angle ABD will also equal half the measure of its intercepted arc. And that's by the inscribed angles conjecture, which I'll abbreviate as IA. Now, what am I trying to show? I'm trying to show that angle ACD is congruent to angle ABD. So I'm trying to show that these two inscribed angles are congruent to each other. Now, I'll also notice that I'm probably going to be using substitution because I have two equations and they're both equal to the measure of arc AD. So I could say then that these are the same. By substitution. All right, and that's what I'm trying to show. So it looks like I'm ready to write my proof. So we'll start with what you're given, that circle O with angle ACD and angle ABD inscribed. In arc ACD, and that is given. Go ahead and do it in the flowchart style here. And because of, it's going to be working down here. So that's going to mean that the measure of angle ACD equals 1/2 the measure of arc AD That is by the IA conjecture. And that's also by interior angles. Now what will happen then is that the measure of angle ACD will equal the measure of angle ABD. And that's going to be, put arrows there, because of substitution. All right, there's my flowchart proof. It's going to clarify that that's the inscribed angles conjecture. Okay. Next is number 2. Angles inscribed in a semicircle are right angles. We have circle O with diameter AB and angle ACB inscribed in a semicircle ACB. Show that angle ACB is a right angle. Let's go ahead and make some observations. Again, we have angle ACB is an inscribed angle. AB is a diameter. That's going to mean that arc ABD is a semicircle. Hold on, I think I got the word letters backwards. There, ADB. We also have that arc ADB is it's an intercepted arc. And it's intercepted by the inscribed angle ACB. So if we look at our, what else do we notice here? Let's see here. Oh yeah, we know that the measure of the inscribed angle is equal to half the measure of the intercepted arc. And since that intercepted arc is a semicircle, that's going to equal 180 degrees. Well, we have 2 different equations, so it's probably going to be using substitution more than likely. Okay. I'd say we're about ready to write our proof. I do like to just look at what are we trying to show. Well, angle ACB is a right angle, which means trying to show that the measure of that angle equals 90 degrees. So this angle right here is 90. Okay, let's go ahead and write our flowchart proof. So we'll start with what's given. Okay, that's given. Well, since it's diameter, that's going to mean that And from here, we can also say that this is going to be the IA conjecture. Reason that this is a semicircle has to do with the and that's going to mean that so we can then, what's going to be the next step? Well, the next step is going to be substitution. So we can go that, actually, I'll make this a little bit bigger, actually. So I'm going to go ahead and substitute in 180 degrees for the measure of arc ADB. And that's going to mean the measure of angle ACB equals 90 degrees. So that's going to be substitution. And simplify. And so from there we can say that angle ACB is a right angle. And that's the definition of a right angle. All right, well, there is the flowchart proof for proving that angle ACB is a right angle. All right, I'm going to pause there and do number 4 in the next video.